Hi, this is Mrs. Ward, and I am going to go over the 9.1b classwork, which covers parabolas. So just a real quick note, I want to go over some of the terms that you learned in the video last night. If you have a standard form of equation of a parabola, you will notice that only one variable is squared. So in this first example, the x is squared. Whatever squared is on one side by itself, it'll always have a coefficient of 1, and then everything else will be put on the other side. If the x is squared, it's a parabola that you're used to. It'll go up or down, depending on whether that 4p is positive or negative. That p, that coefficient in front of your term that's linear, is going to determine how wide the parabola is. So I graphed two real quick. This first one in red is x squared is equal to 4y, which means in this case p would be equal to 1. And that's the red one, which is thinner than the one down here, which says x squared is equal to 12y, which in that case p would be equal to 3. So the p is the distance between the vertex and the focus. So the smaller this number is, the closer to the x-axis it'll be. I'm sorry, closer to the y-axis it'll be. So let's go over some examples from the classwork. The first set, 37 through 42, you're supposed to match the equation to the parabola. So if you're going back here, if the x is squared, we know my parabola is going to open up or down. If the y is a variable of squared, the parabola is going to open to the left or to the right. If it opens up, the 4p is positive. If it opens down, the 4p is negative. If it opens to the left, the 4p is negative. If it opens to the right, the 4p is positive. So when I look at these, I'm going to separate them by whether they open up or down, or whether the x is variable squared or the y variable squared. So looking at number 37, let's just start with 37. 37 has the y squared. So what I'm going to do is I'm going to look at all the ones that have the y variable squared. So 37, 40, and 41 are the three equations where the parabola is going to either open to the left or to the right. So when I look at these, I'm first going to see 37 negative, so I know that this one opens to the left, and it has an origin, it has the vertex at the origin 0, 0. 40 is also to the left, and it has a vertex at the origin, which is 0, 0. So when I'm looking up here, these two are the two that open to the left or the right. They both open to the left. So I now have to decide which one of these is 37 and which one of these is 40. But if you remember from the previous slide, the one that is narrower is going to be the one that has a smaller coefficient. So in this case, 37 will be E. So I'm just going to write over here that 37 is E. And then over here, the wider parabola is going to be 40. So 40 is going to be the letter F, which by process of elimination, that means that A will have to be 41. But let's look at that for a second before we just jump there. I know my vertex is going to be whatever I'm subtracting from x, which is 3, whatever I'm subtracting from y, which is 1. So my vertex is 3, 1, and this appears to be 3, 1. And I know since it's a positive, it's going to open to the right. So 41 is, in fact, going to be the letter A. The remaining ones that I have left are going to be 38. Oopsie, thought I changed colors there. 38, 39, and 42. All three of those have the x squared, which means it's going to either open up or down. So when I look at these equations, 38 is going to open up, and it's going to have the vertex at 0, 0. 39 is going to open down, and it's going to have the vertex at 0, 0. And 42 is going to open down because of that negative sign. And its vertex is going to be at -3 because technically I'm subtracting a -3 to get that +3, and 1. So the two that are at the origin are this one and this one. This one we said had the origin, but we said it was going to open up. So 38 will be the one that has a vertex at the origin and opens up. So 38 will be B. The one that has a vertex at the origin and opens down is going to be, where did that one go? 39. So that's going to be D. And then finally, this one by default, C, has to be 42, but just checking the vertex is at negative 3, 1. It does open down. So that's why 42 is going to be the letter C. I hope I got those all right. I'm sure you'll let me know if I didn't. All right, so the next one, it says find the standard form of the equation of the parabola and the vertex. Oh, let me read that again. Find the standard form of the equation of the parabola with the given characteristics, and the vertex is at the origin. So the vertex is at the origin, which means my HK combo is going to be 0, 0. So I like to draw a quick little sketch. I know my vertex is at the origin. It tells me that the directrix is at x is equal to negative 3. So I'm going to go over the negative 3. X is equal to means that it's a vertical line. So I'm going to sketch that vertical line in there. My parabola has to go through the vertex, and it has to open in the opposite direction of the directrix. So the distance from here to here is 3 units, but it's 3 units to the left, which means the distance from my vertex to my focus is also going to be 3. Since it lays on its side, it's opening to the left or the right, the y is going to be what squared? So I'm going to have y squared is equal to 4. In this case, the p is the distance between my vertex and my focus, which in this case is 3, and then I'm going to have x. My final form in simplified form is going to be y squared is equal to 12x. The next one, remember I'm still going through the origin, so I still have the vertex at the origin, and I pass through the point 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 4, 6. So I pass through that point, but I don't know if my parabola is going to go this way or if my parabola is going to go this way. It tells me that I have a horizontal axis. An axis is what cuts the parabola in half. So this horizontal axis is going to have to go this way because that's a horizontal line. So it's going to have to go this way that cuts my parabola in half, which means this point is going to go through here, and my parabola is going to look something like that. Again, it's laying on my side, so I might know my y is squared. Y squared is equal to 4. I don't know anything about a directrix. I don't know anything about a focus, so I have no idea how to find my p. I'm going to have x. So this is the way I'm going to write the equation at first. I noticed that they give me the ordered pair 4, 6. And the reason why they give me that is because now I can substitute that in for my x and my y. Because right now I have 1, 2, 3 unknowns. They're giving me 2, so then I can find the third. So I'm going to write 6 squared, because that's my y, is equal to 4p, and then x is 4. So I'm going to have 36 is equal to 16p. P is equal to 9/4 when I divide both sides by 16. So now I'm going to take that 9/4, I'm going to substitute it back in here for that p. So I'm going to have y squared is equal to 4 times 9/4 times x. The 4's will simplify, and I'm left with y squared is equal to 9x. And that's my standard form of the equation of the parabola. Moving on to the next one. It says find the vertex, focus, and directrix of the parabola and sketch its graph. So as you noticed on every single one, whatever squared is on one side by itself. So I'm going to take this x squared is equal to negative 8y. I have to make sure that this has a coefficient of 1, which it does, so there's nothing else I can do. This would be in standard form. I notice that I'm not subtracting anything from my x or my y, so my vertex is going to be at the origin. So my vertex is at 0, 0. Then I'm going to do a real quick sketch over here, vertex at the origin. Then this negative 8y is equal to 4p. Which means 1p is going to equal negative 2. Well, the p is the distance between the center and the focus. The x is squared, so I know it's going to either open up or down. Because of this negative sign, I know it's going to open down, something like this. They're telling me my focus is 2 units away from the vertex, so I'm going to go 1, 2. So here's my focus. So my focus is going to have the ordered pair of 0 -2. And then it wants the directrix. The directrix will go the same. So this is 2 units from the vertex to the focus. I'm going to go 2 units in the opposite direction. It's going to have to be a horizontal line so it doesn't touch the parabola. So a horizontal line will be y is equal to 2, and that's going to be my directrix. Moving on to the next one. Here I want to find the vertex, focus, and directrix of the parabola and sketch its graph. So I'm just going to start my sketch over here. I'm going to put my x's together, my y's together. Anything that doesn't have an x or y is going to go over to the other side. So I'm going to have x squared minus 2x plus 8y is equal to -9. Ooh, I'm actually going to take the 8y over to the other side too. X squared minus 2x is equal to -8y minus 9. Because I'm only going to have one thing squared on this side. On this side, I'm going to have to complete the square. So I'm square root of x squared is x. This is a minus sign, so I'm going to copy down the minus sign. I'm going to take half of 2, which is going to be 1, and then 1, -1, or 1, however you want to think about it, doesn't matter, because when I square 1 or -1, it's going to be a positive 1. So I have 1, I'm going to add 1 to this side, which means I have to add 1 to this side. Then I end up with -8y, and then when I add 1, I'm going to have -8. This is, I'm going to leave as x minus 1 squared is equal to here. Whatever this coefficient is of y, that's what I'm going to factor out, whether or not it goes into this perfectly or not. So I'm going to factor out -8 and be left with y plus 1. Now it's in standard form. I can get all my information that I want from here. So the first thing I'm going to say is that my vertex is going to be whatever I'm subtracting from x, which is 1. Whatever I'm subtracting from y, which would be -1. So at 1, -1 is going to be my vertex. This -8 is equal to 4p, which means p is equal to -2. That's the distance between my vertex and my focus. Since the x is squared, I know it's going to open up or down. Since this is negative, I know it's going to open down. So my parabola is going to do something like this. And then my focus is going to be 2 units down, so it's going to be down here. In that order pair, the x coordinate is going to stay the same, so that's going to be 1. And then my y coordinate, I'm going to subtract 2 from that and get -3. So that is my focus. The last thing I need is I need the directrix. Remember, the directrix goes 2 units in the opposite direction. So I'm going to start here and I'm going to go up 2. And that's going to be a horizontal line, so it does not touch the parabola. So that's going to be y is equal to a +1, and that's the directrix. And how I got that is I went back up to this -1 and I added 2, and that's how I get y is equal to 1. All that is on your formula sheet on the bottom where you're looking at the parabolas. So if you're confused, remember you'll have that formula sheet with you for any tests or quizzes. Find the standard form of the equation of a parabola with the given characteristics. So they're telling me that the vertex is at -1, 2. I'm a visual, so I'm going to draw this. -1, +2. There's my vertex. The focus is at -1, 0. So there's my focus. Remember, the parabola has to open around the focus. So it's going to go something like that. So that tells me a couple things. First of all, it tells me that the p is going to be negative. It's telling me that it opens down, which means that the x variable is the one that's going to be squared. So I'm going to have x minus a -1, which would be x plus 1 squared, is equal to 4p, and then y minus 2. This plus 1 and this 2 come from the vertex. Now the p is the distance between the focus, and the vertex, which is 2 units away. So I'm going to have x plus 1 squared is equal to 4. And then since it's going down, I'm going to make that a negative 2, y minus 2. So I'm going to have x plus 1 squared is equal to negative 8 times the quantity of y minus 2. And that's my parabola in standard form, and I don't think it wants anything else besides that. Moving on to number 81. This one tells me my focus is 2, 2. So my focus is the order pair 1, 2, 1, 2, 2, 2. The directrix is x is equal to negative 2, 1, 2. So that's a vertical line. Goes like that. The vertex is going to be halfway between the focus and the directrix. So it's going to have to be at that same height. So it's going to have to be at 2. It's going to have to be 2. And then I need the halfway point between 2 and negative 2. And I can either count on my graph or do the midpoint formula between those two, but it's going to end up being 0. So my parabola is going to do something like this. So the vertex is going to be 0, positive 2. And then since it's opening to the side, it's the y is going to be squared. So I'm going to have y minus 2 squared is equal to 4p. Do I know the distance between my vertex and my focus? And I do. It's going to be 2 units away, so that's going to be 2. And then this will be x minus 0. So I'm going to end up with y minus 2 squared is equal to 8x. I can write a times the quantity of x minus 0, but I don't have to, so I didn't. Okay, the next one, the beam deflection. So you have this worker who's on this beam that's 64 feet long. And he's standing at the center. And what he notices when he's standing at the center of this, from here to here, 64 feet, what he notices is that he goes down 1 inch. Like the board kind of bows 1 inch. And so it wants me to find the equation of a parabola, assuming that the origin is at the center of the beam. So they're telling me where to put the origin. And I'm going to go over here and do my best to draw just what's going on here. So I have this beam that's going like this. If the origin's at the center is actually lower. So I have this point here, which is 0, 0. That will be my origin. From here to here, let's say, is going to be that 64 feet. Okay. If I wanted to name this point right here, that guy right there, it would be 32 feet, right? Because half of that beam would be 32. And then he's up 1 inch. 1 inch. The problem with this right off the bat is I have 32 feet and I have 1 inch. So I'm either going to have to convert the inch to feet, or I'm going to have to convert the feet to inches. Do you guys want to work with fractions, or do you want to work with really big numbers? I think you guys would choose really big numbers every day over fractions, but I wouldn't. But I'm going to go with you guys and say, okay, this 32 feet is really 384 inches. And then this is 1 inch. Okay, so let's work with that. So since the vertex is at the origin, I don't have an h or a k. It opens up, so I know that the x is squared. So I'm going to have x squared is equal to 4p y. Now I have this ordered pair, 384, 1. So I'm going to substitute that in. So I'm going to have 384, and this is x, that's going to be squared, is equal to 4p times 1 inch. So when I take 384 and I square it, now again, these are going to be big numbers, but you do have a calculator. So 384 squared is 147,456 is equal to 4p. Let's take a second here. I want to write the equation, right? And I know that I have 4p here, right? I could divide by 4, and then I'm just going to end up multiplying by 4. I could do that, but why bother? So I'm just going to say x squared is equal to that 4p is going to be 147,456y. So that's my equation. The standard form of the equation in inches. And then it says, how far from the center would the beam, so that's A. And you know, I'm wondering if we did this all in feet, and this is inches, if I divide that by 12, because I think your book's answer does it. If I did this, this is in inches. If I did it in feet and divided this by 12, I'd get the equation x squared is equal to 12,288 times y. So those are the same because this one's in feet, that one's in inches. These are the same equation, exact same equation, different units. I'm going to stick to this guy here because the next question asks, how far from the center of the beam is the deflection equal to 1/2 inch? So this is basically saying, what is x when y is equal to 1/2? So I'm going to say x squared is equal to that 147,456 times 1/2 because that's what my y is. So when I multiply that by 1/2, I get x squared is equal to 73728. And now I'm going to take the square root of this side, square root of this side. I'm going to get x is equal to, technically, plus or minus, and I'm going to explain to you why that makes sense in a second. And when I take the square root, I'm probably going to get a decimal. I do, and I get 271.529. And you're going to say, well, wait, Mrs. Ward, that's more than the 64. Well, yes, that is more than the 64, but that's because this is in inches, and then if I divide it by 12, that would put it in feet. And when I do that, I'm going to get, this is inches, and it's going to be 22.6, approximately 22.63 feet. And the plus or minus does make sense because if I go back up to this problem here, it's going to be 1/2 inch over here, which would be the negative, and it's going to be 1/2 inch over here, which would be the positive. So in this case, this is one of the few times where a positive and a negative do make sense in a word problem. And that's how you do the homework. Oh, wait, do I have one more? No, that's it. I hope this helps. Remember, we will have office hours. You can ask a question. Just log on and come see us. All right, good luck.